Hello, friends. This morning we are treating the topic solving problems using basic equations. Solving problems using basic equations. So we are going about this important topic. Right. So first I'll start by introducing what is meant by solving problems by using basic equations. And so I'll start by telling you that when we actually mention problems using basic equations, equations are actually important and they are fundamental tools that help us to solve real world problems by actually representing the relationships between numbers and variables. Basic equations often involving addition, subtraction, multiplication, or division allow us to find unknown values in a systematic way. And so understanding how to set up and solve simple equations is an essential skill. In today's lesson, we will delve into how to approach and solve problems using basic equations effectively. Let's get on right away. Let's take note of this. One, when we say x plus y, what it means is that y is to be added to x. X plus y means that x is a number and we are adding y as a number to it. X plus y means that y is to be added to x. Now, 2, a minus b means that we are subtracting b from a. 3, p divided by q or p on q means that we are going to divide our p by q. Sometimes we write this in a sentence form and you translate it into the mathematical expression. 4, a letter can represent any number. A letter can represent any number. Right. 5, x times y can be written as x dot y or xy. So when we are multiplying letters, we can introduce the multiplication sign or using the dot to represent the multiplication sign, or xy when we are using letters. But if you're writing 4 times 3, that one, you can write it this way because it will be 43. But we normally use this or we can use that. 6. Let's now move into the sentences aspect. When 5 and a are multiplied, we have 5 times a because we are multiplying a number and a letter. Or we can write 5a. We can omit the sign with the understanding that 5 is multiplying a. So you can write 5a, but not a5. Always the number will come first and the letter will come second. So 5a, but not a5. Let's take note of that. 7. Now, to multiply the sum of a and b by 3 is written as. So first you find the sum of a and b, and that is a plus b, and that is seen as one number. Then you multiply the result by 3. So you enclose them in a bracket, and they multiply by 3. So to multiply the sum of a and b by 3 is written as 3 into brackets, a plus b, brackets closed. Right, so the whole of this sentence up to this point has been captured succinctly in this form. So the whole of this is for this sentence up to that point. Now, 8, to add x and y and subtract the result from p is written this way. So first, we add x and y. So x plus y, we enclose them in a bracket. And this result, we are going to subtract it from p. And so write p minus brackets open x plus y, brackets close. So whatever we have here, when we compute it, we subtract it from this. So p, x, and y will all represent numbers. Great. 9. Now to multiply the sum of a and b by 5 and divide the result by x can also be written as. We find our sum, we multiply by 5, so we enclose them in a bracket as we did previously. And then because we are dividing this result by x, so all over x. So look at it carefully. We are multiplying the sum of a and b, so a plus b, by 5. So a plus b in a bracket, this is seen as one number, times our 5, divided, the result divided by x. So the whole of this expression up to this point has been captured in this mathematical expression. To multiply the sum of a and b by 5 and divide the result by x is written as 5 into brackets open a plus b brackets closed all over x. So that's how we translate sentences into mathematical expressions. 10. So in this expression, 2a plus 3, we say that 2 is called a coefficient. Coefficient. A over here is a variable. It can change. You can put various numbers there. And when we have an equal sign, that will give us what we normally actually wish to get. And the 3 here is called a constant. So 2 is a coefficient, a is a variable, and 3 is a constant. Thank you so very much. We shall continue and do real-world examples that will help you and throw more light on this. But before then, take your time and go through what I've treated today and make sure you understand how we translate sentences into mathematical expressions. The next aspect I will be doing is that we will now be equating them to items that will be supplied. Thank you for your time and have a blessed day. Bye.